Hi there, so in this video I'm going to be teaching you how to classify stationary points. Now here I'm using the same function that I found the stationary points of in my last video, and I'm going to be using the results that I found in that video, so you might need to have a look at it. So, first thing I'm going to need is the derivative, and I found in the last video that f prime of x, the derivative, equals 3x squared plus 21x plus 30. And also I'll need the stationary points, which I found to be -2 and -5. Okay, so now I'm going to use what's called the second derivative test to classify these stationary points. So, as the name suggests, I'm going to need to find the second derivative. So, that is just when you differentiate the derivative, or differentiate the function twice. It's denoted by f double prime of x. So I'm just going to differentiate this expression here, which gives me 3 times 2x plus 21, and 30 differentiates to 0, so that comes out as 6x plus 21. Okay, now I'm going to substitute the stationary points into this. So, for -2, 6 times -2 plus 21 is 6 times -2, or -12 plus 21 equals 9, which is positive. And the second derivative states that if the second derivative evaluated at the stationary point gives a positive number, then the stationary point will be a local minimum. Okay, so -2 is local min. Likewise, let's work it out for the -5, so 6 times -5, or -30, plus 21, that's going to be equal to -9, and that's negative. So, as you may have guessed, that means that the stationary point is local maximum. So, -5 is local max. Note, if you get a 0 when doing the second derivative test, that means the test is inconclusive, so you can't draw anything from that. And this is, you might want to consolidate these two results into one conclusion, but that is pretty much it. So that was how to classify stationary points using the second derivative test. Thank you.